Thank you everybody for being awake still. So my last name is Chereches, which is very Hungarian. Unfortunately, I don't speak any Hungarian, so you would have to apologize me for this. The presentation is going to be in English. So what I'm going to try to introduce you is the OPSWAT portfolio and our way to protect the critical infrastructure. So let me just start by showing you the agenda. Most of you, or some of you, probably didn't, or it's the first time you hear about OPSWAT. So I want to speak to you about the company quickly. We'll kind of like paint the picture of how the OT and industrial control system looks like in the last couple of years in terms of threats. We're going to look at the OPSWAT solution for that, and hopefully you can stop by our booth to actually see a demo. Right, OPSWAT, it's not a new company, it's not a startup. It's actually a 20 years old company. We started in 2002 in San Francisco. That's where the headquarters was. We kind of like recently moved headquarters from San Francisco to Tampa after we have acquired the company. So a couple of milestones. In the last couple of years, we have acquired 3 companies in total. We got a round of investment of $125 million. I'm actually from Temesvar, which is not far from here. When I joined the company over 4 years ago, we were 20 people in the office. We're over 70 now. And like it was said, we also have an office in Veszprém that's growing as well. So we're on a hyper-growth scale, and we have a lot of customers. What you see here on the screen are the 16 different industries that are considered critical infrastructure by the US government. OPSWAT obviously has customers in all of them, right? We are striving to be the global critical infrastructure protection, cybersecurity in the industry. We have a global presence. I mentioned the office in Romania. There's an office here in Hungary, but there's all offices around the world. We have a total of 11 offices with over 500 employees globally and over 70 technology partners. Some of them I can see today, but there's many more. Right, let's look at what are the challenges in this space, which it's quite hot in the last, let's say, maybe 2 years. So we see a lot of news in terms of what are the threats and what type of attacks target critical infrastructure. Right, critical infrastructure are those 16 different industries. If we look at water and wastewater management, the attacks have increased over 100%. And that's what we see in the news, right? Energy sector, again, consistent increase in the number of threats. Critical manufacturing, almost 90%. There's been a study done by Kaspersky where they actually discovered that 33% of computers that run in those networks were attacked. But those are just engineering workstations that they took into consideration. They didn't really look into the OT equipment per se. So that figure is probably slightly higher. Those are just some examples that you're probably familiar with. The OPSWAT attack, when they got access to actually change the chemical percentage in the water in Florida, and Colonial Pipeline, we all know. Right. We're very close to where the action happens, unfortunately. So cyber warfare is not something that we just hear in the news. It's something that we need to be very, very prepared for. And all the governments in Eastern Europe are going to beef up defenses. They're going to increase the spending in cybersecurity, because cybersecurity is now a space and it's considered part of the entire warfare. So you see there some examples of attacks that have happened recently. and this is my favorite, it's actually quite simple. The threat actors started posting USBs, malicious USBs, in an Amazon gift box to government employees. And obviously, we're very curious as human beings. So someone would actually take that and insert it in their computers, right? It always happens, right? It's a numbers game. If you send a bunch of them, there's going to be someone that does that, right? They also did it like it's coming from the Department of Health in the US as a COVID letter. Right, is there a solution to all that? We think there is. And let me just introduce you the OPSWAT vision to how we can protect critical infrastructure. So we do it in 3 steps. One single platform. One platform that can cover threats from IT to OT and the emergence of the two, right? It's very important that the solution is flexible, right? So we have to support all types of deployments. Cloud, air-gap, which is essentially offline deployments. But that platform has to be very robust. So step 2 is to combine multiple technologies under the same platform. 2 of the most important technologies that we rely on are multi-scanning, which essentially combines multiple antivirus engines that would scan files at the same time. So we can provide anywhere from 5 AV engines up to 34. That's 3, 4, all running on premise. Nothing leaves the network. There's no cloud connection. Doesn't even need an active internet connection to run. Right? So that's one of the technologies that we rely on. The other is a technology called Deep CDR. CDR stands for Content, Disarm, and Reconstruction. And what the technology does, it looks at productivity files, 120 of them. Office documents, PDFs, images, video files, all the documents that we use on a regular basis. It de-weaponizes them, so it removes components that can actively run code. Macros are the most popular ones and the most exploited ones, I would say. But there's so many other components that can be exploited with malicious intents. So we remove all that. We recreate the file, keeping the same file format, but the file that we create is safe. It won't be able to run any code on the endpoint. So we combine 2 technologies under the same platform. Multi-scanning, which is detection-based, CDR, which is pure prevention. Right? There's no detection involved. We're going to remove the active components every single time. Why do we do that? The antivirus detection or any detection-based technology, it's not good enough to detect every type of malware, right? There's no such thing as 100% detection. That doesn't exist, right? So we need to add more and more layers to make sure the organizations that are using our technology are safe. And those layers have to work differently, right? That's why we take different approaches, right? Detection, prevention, one single platform. We all complain about not being able to find the right people, right? So that's a fact. There's a shortage of skilled people in cybersecurity. And what we're trying to do is actually help with the user education, especially in the OT, so in the operation technology part of the picture, where you have to have very skilled engineers that can understand OT-specific protocols, OT-specific processes, and things like that, right? So part of the academy that you can find on OPSWAT.com, it's free, so you can get some free training on IT and OT. There's also some paid trainings, and that is continuously improving with content. Right, some of you might recognize this reference architecture. This reference architecture is called the Purdue model. It's been introduced by the Purdue University in the US, and it's the golden standard for how ICS networks and operation technology works and how those networks should be designed. Right, the purpose is to segregate all the layers and to place the most important equipment At the lower levels, where access is heavily restricted. OPSWAT has technologies at every of those levels, right? Remember the initial slide where I told you we have one platform that can do IT and OT cybersecurity? This is where you can actually see a visual representation of that. If you look at the level 5, which is enterprise IT, right? It's the cloud, right? We have solutions for the cloud. Every blue icon you see there, it's an OPSWAT product that can scan files and secure files in that specific part of the network. If we look at that, like for MetaDefender storage, for example, which you see up there, that's our product that's able to scan files from cloud storage workloads. Amazon S3 buckets, Microsoft OneDrive, Dropbox, Box, you name it, those files can be analyzed by us with up to 34 different antivirus engines and providing CDR, deep CDR, right? So de-weaponizing those files and providing the user with a safe copy of that file. We have an ICAP server. If we move at level 4, we have an ICAP server. ICAP, it's an industry protocol that is able to offload file security from different networking devices, like firewalls, proxies, web application firewalls, and so on. It's a very light form of HTTP, right? So we can integrate with those products to allow file scanning and deep CDR at the network level in the DMZ. And I'm going to show a diagram of how that works slightly later. 3.5, anything that's 0.5 in this architecture, it's actually a DMZ. This is a very simplified one. You can have DMZs in more of those levels. But if it's 3.5, that's the convergence between IT and OT networks, right? That's where a big attack surface exists, and it's represented by transient assets, or simply put, USB drives. People bringing USB drives with data that has to be transferred into the OT network. Let's imagine, there's a nuclear power plant in Hungary, right? That runs this type of security architecture. And there's a lot of equipment that runs in the lower levels that need to be updated, patched. So there's going to be a continuous flux of contractors coming with all kind of portable media to patch their devices. Siemens, Rockwell, ABB, you name it, right? If they have equipment, they need to update it, and they almost every single time bring a USB or a CD. Now, the nuclear power plant is just not going to accept any USB and trust the vendor that the files are safe. That's why we have supply chain attacks, right? That's why we need to have proper solutions to protect against those type of attacks. So the kiosk that you see there, it's a machine, and we also have it at the stand, which is just around the corner. If you want to stop by and see a demo after this, I'm happy to show you. It's essentially a machine that can process all kind of portable media. CD, DVDs, USB drives, mobile phones, external hard drives, you name it. You can plug it in, it scans the files with all the AV engines that are on that box. We have 8 on our machine. Like I said, we can go all the way up to 34. We sanitize the files. Then the next step is through an OPSWAT net wall, which is a unidirectional gateway or a data diode. We transfer the files one way. So we don't want anything that's in this OT network to leave the network. That's why we need to use a unidirectional gateway. The data that then gets transferred, and in level 3 it gets stored on a vault. It's a file vault. The files get stored there. The beauty of this process is that from this moment on, there's no need to use any USBs. The kiosk is usually placed in the reception area of that building. You go, you scan your USB, you get a receipt, and with that receipt, you can then retrieve the files from the vault from any engineering workstation. So we literally help eliminate the USBs in the OT network. So that's removing probably one of the biggest attack surfaces that exist in this network. Right? There's been studies done by different organizations that have discovered the USB usage is actually increasing in those networks, right? We have so many great security technologies to help move away from the USB usage. The opposite happens. Why? The people that operate the OT environment, they're not IT people. They're hardcore engineers, right? They resist change. They use USBs for 30 years, 40 years. They're going to use USBs in the future as well. If we move lower, we have products like OT Fuse, which are an industrial IDS. It literally sits in front of the PLC and makes sure that the PLC doesn't send strange commands, doesn't run any commands that are outside of the time frame where it should run commands. So it's not a solution that's been repurposed for OT environment. It's a solution that was designed for OT environment. Supports all the popular protocols, for example. Right. That's how the kiosk looks like in reality. There's two versions of the kiosk. The very big one, it's probably the size, it's just my height. It's the size of an ATM. Heavily used by military customers. The other one, it's tabletop. It's an all-in-one. It's better suited for maybe a government customer. All of them use that multi-scanning technology, that deep CDR technology. We can check if there's sensitive data in the files that exist on that USB. We can check if there's known vulnerabilities on those files as well. So if we determine there is a file that has known vulnerabilities, we're not going to allow the file to be transferred in the network. This is a very simplified diagram of how the process can look. We have the kiosk. Again, going back to my example with the nuclear power plant, we're in the reception area where we have the kiosk. I'm a contractor, I bring a USB, I plug my USB here. There's going to be clean files and infected files. We don't care about the infected files stay on the USB. We only transfer the clean files through a unidirectional gateway in the OT environment. I have transferred the files now into the ICS network, and the kiosk printed a piece of paper for me with a code, and that's how I can actually download the files that I had on my USB. So once I'm in this network, all the USB ports on all the computers are actually blocked. So just retrieving the files from the vault, it's my only option. So I can sit out at an engineering workstation, open a web browser, go to the vault, put the code, and download the files. No USB is introduced in the network. Sounds ideal, and it's ideal. It doesn't really happen like this. Like anything in security, we need to add exceptions. The second we created the process, there's going to be someone that comes and asks for some exceptions. And those exceptions are workstations that have to take USBs for different reasons. How do we protect those? When we scan the USB in the kiosk, we sign the USB, and if there's any change in the data of that USB, we're not going to allow it to be mounted if that workstation runs the OPSWAT client. If I change the USB with a different one to try to bypass the process, it's not going to be mounted. The client would only accept the USBs that have been scanned by the kiosk in the last 24 hours, and if the data is the same. There's obviously a solution that can help us protect specialized equipment like PLCs or HMI machines, right? Solutions or devices where you cannot install a client. You cannot install a client for different reasons. The vendor doesn't allow you. It runs a proprietary operating system and so on. So there's this small hardware box. It's the size of a Raspberry Pi, which becomes the USB interface. And that's where you plug in the USB. And it does essentially the same thing, right? If you change the data on the USB, you're not going to be able to transfer anything to that HMI to do your configuration. That was one of the use cases for the OPSWAT technology. The other one is to actually use the same technology, multi-scanning, CDR, DLP, and scan files that are received by the enterprise IT network. Right? Very popular with banking sector, for example, where you have, let's say, a mobile application or a web portal where your customers can upload files. We can protect those files. How do we do it? It's very simple. Through ICAP protocol, we can integrate with web application firewalls, proxies, pretty much anything that front ends that web server. We can be there. Anything in terms of files that goes through the solution that we integrate with, it's going to be scanned and sanitized by us in a second. Right? It literally takes a second per file to scan with multiple AV engines and create a clean copy of that file, which that clean copy is the one that's actually stored in the network. So if you have, let's say, a mobile banking app that allows users to upload a document to apply for a new credit card, they would upload a document, let's say, that contains JavaScript. Let's say it's a PDF. By integrating OPSWAT into the WAF, let's say, we can scan that document with multiple AV engines. We create a clean copy of that file on the fly. And you end up with a PDF in the database that cannot run any active code. And this is a technology that can help block zero-day attacks, because it's not detection-based, like I said. We're going to remove all the active content every single time. And by doing so, we obviously increase the security posture by a lot. Right, I'm 2 minutes out. You see some logos there. That's just some of the logos that we integrate with. Long story short, anything that supports ICAP can integrate OPSWAT to enhance the security of that appliance. I'm happy to take questions. I'm happy to show you a demo. Like I said, we're just around the corner. Stop by and say hi. If you want to know more about the technology and the solution we have, I'll be happy to speak to you. Thank you very much.